In the last video, we started seeing how variables work in Python. In this video, we'll start working with objects. By the end of this video, you should be comfortable with the notion that everything in Python is an object. Well, what do we mean by objects? Well, in programming, an object is something that can hold data and often has methods associated with it. We'll actually be working with more complex objects like lists later this week, but for now, just keep in mind that objects hold data. In the last video, we saw how this code worked with dynamic typing. Specifically, x was allowed to be assigned both an integer value and a floating point value. But why? Well, to figure that out, we're going to have to understand that everything in Python is an object. And for those of you who know C++ or Java, you'll be surprised to see that this applies to primitive types too. In fact, the line x equals 3 on the left is going to cause a PyInt object to be created. The PyInt object is going to hold the value of the object, in this case 3, along with other details for Python to work with under the hood. These features include the type of the object, the number of references to the object, and a bunch others. So let's see how x equals 3 might work, and we can do this by drawing the memory diagram. First, when you say x equals 3, Python will create a PyInt object with the value of 3, and then have your variable x point to that object. For those of you more versed in the details of programming, x is being created on the stack, and the PyInt object with the value of 3 is being created on the heap. The stack holds your local variables and is managed by your program, whereas the heap holds dynamically created data and is actually managed by the operating system. But don't worry if those terms are unfamiliar to you. So what happens when we now say x equals 4.5? First, a PyFloat object with the value of 4.5 will be created. Then, x will be set to point directly to that new PyFloat object. For those of you familiar with C or C++, no longer having anything point to an object should be a big red flag, because that's lost memory. But in Python, that's taken care of for you. The garbage collector in Python will automatically free the space associated with that first PyInt object because nothing is pointing to it anymore. Let's walk through another example. Here we'll create a variable x to have the value 3. The memory model for those two lines of code is below. If you're ever curious to know if two variables are pointing to the same object, you can use the is command. In this case, if we run x is y, it will return true if they point to the same object and false if they do not. Since our memory diagram has them point to different objects, we'd hope the answer is false. And it is. X points to a PyInt object and y points to a PyFloat object. You might be thinking, but wait, these both have a value of 3. Well, if you want to test for numeric equality, you'd use the equal operator. When we test x equals y, we should get back the value true because they both have the same value. And that's exactly what we get. Now you might have noticed that I've been writing code in the shell format. If you want to play with code like I have been, just open up your Python shell, and you can start running commands like x equals 3, y is 3.0. We can test things like we just did. For example, x is y will come back as false. X equals y will come back as true. You can print x if you want to see its value. But you can actually just type x instead. So feel free to play with your code this way as you learn Python. But starting next week in the course, we'll be writing code in Jupyter Notebooks. But for now, let's continue learning about Python in our next video.